Good morning, dear children. Today we will discuss the term electromagnetic spectrum. So before we come to that, the electromagnetic spectrum, let us discuss electromagnetic waves. Now, the experimentally that it has been found that when the light bends, that means when the light passes from one medium to another, okay, and when it bends, they behave like a wave. When the light bends, they behave like a wave. And this behavior of light, like a wave, they are known as electromagnetic waves. And the waves which are associated with the light, they are known as electromagnetic waves. And electromagnetic waves, like we have discussed about the visible light. The visible light means is having 7 different colors here. But beyond that, red light, beyond the red light and the violet light, there are other light rays are also there. Okay, but we cannot detect that. We cannot see. And all the light rays beyond red and beyond violet, they are all associated with the light. Okay, we know that the light given by the sun consists of a white light, and that white light, in the white light there is a mixture of 7 different colors. And these 7 different colors you will see when the white light falls on the prism, and from the prism the light get dispersed, and the 7 different colors you will see on the screen. And that 7 different colors of light we call it as a visible light, because we can see that color. Okay, and beyond violet and red also there are some rays are there, light rays are there, okay, which we cannot see. And these light rays are combined or associated with the entire white light. So therefore, when we discuss about the electromagnetic waves, so electromagnetic waves not only comes under the visible light, but there are the other waves, other rays are also there, which are associated with the visible light. So they are gamma rays, X-rays, ultraviolet radiation, infrared radiation, microwaves, radio waves. All these are the electromagnetic waves. And the waves which are associated with the light, we call it as electromagnetic waves. And why we call them as a wave is because when the experiment has been found that when they bend, they behave as a wave. So they are known as electromagnetic waves. And these electromagnetic waves are classified according to their wavelength and frequency. So depending upon the wavelength and frequency, they are classified. So this orderly classification of electromagnetic waves in terms of wavelength and frequency, now we call it as electromagnetic spectrum. Okay, so they are known as electromagnetic spectrum because they are classified. The electromagnetic waves are classified according to their wavelength and the frequency. Okay, so now according to these electromagnetic waves are associated with the light, and their speed is same as that of light, that is 3 into 10 to the power of 8 meter per second. And the relation between the frequency, wavelength, and the speed of the light is given by the relation c equals to lambda f. So c is the velocity or the speed, lambda is the wavelength, and f is the frequency. So from here we can get that the electromagnetic spectrum, which we call it as electromagnetic spectrum, all these are associated with the light. They are not away apart from the light, but they are consist in the presence of light. So likewise, when the sun rays, the solar rays, which is given by the sun, it consists of visible light. You know that. But apart from that, it also consists the other rays there, which we cannot see. They are the ultraviolet radiation and the infrared radiation. Apart from this visible light, okay, the solar light has got two more radiation present on them, but we cannot see. They are the ultraviolet radiation and the infrared radiation. So this ultraviolet radiation, infrared radiation is also associated with the light. So all of them are considered as the electromagnetic waves or electromagnetic spectrum. And we call electromagnetic spectrum because these waves are classified according to the wavelength and the frequency. Now you can see here the 7 electromagnetic waves are here. Now these waves are classified according to their wavelength. Okay, wavelength. So according to the wavelength, okay, by increasing order. So the least is gamma rays, X-rays, then after that ultraviolet radiation, then visible light, then infrared radiation, microwaves and radio waves. So radio waves has got a higher wavelength. Okay, and the least wavelength is gamma rays. But when we consider in a visible light, the least wavelength is at violet. Maximum wavelength is red. But I told you that beyond red and beyond violet also there are other spectrum or other electromagnetic waves are also there, which is merged or which is associated with the light. So therefore, apart from after red has got a maximum wavelength. So after red, what will come here? Then comes infrared radiation, then microwaves. After this comes infrared radiation, microwaves, then comes radio waves. Then after that, violet. After violet comes the ultraviolet radiation, X-ray and the gamma rays. So that is beyond this visible light also we can find other spectrum or other electromagnetic waves. So together, all of them are associated with the light. Okay, but this part beyond red and beyond violet we cannot see them. We cannot see the spectrum, though they are related with the light, associated with the light, but we cannot see them. Okay, so therefore all of them consider beyond red as well as the violet color of light, the other radiation which are present, okay, they are considered as the electromagnetic spectrum. Okay, so now the next one is there, that is the characteristics of the before that characteristic. Now let us come to the frequency. Okay, frequency. Next one is the frequency. Now according to the wavelength, increasing wavelength, first comes gamma rays, X-rays, ultraviolet radiation, visible light, infrared radiation, microwaves and radio waves. But depending upon the frequency, the least frequency is radio waves. Then after that comes microwaves, infrared radiation, then visible light, then ultraviolet radiation, then X-rays, then gamma rays. So that is in terms of frequency, gamma rays has got a maximum frequency. Okay, so you just interchange that. So we have written a 1 to 7, okay, as the increasing wavelength, and when you change, in terms of wavelength, we have written from gamma rays to radio waves, but in terms of frequency, F. Now you write first radio waves, then after that microwaves, then infrared, then visible light, then ultraviolet radiation, then X-rays, then gamma rays. Okay, you just please remember that. Okay, so depending upon the increasing, write the electromagnetic waves or electromagnetic spectrum in the increasing wavelength. Sometimes the question will come. So increasing wavelength means you write this one. Increasing frequency you start writing from the radio waves. First you write radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and the gamma rays. Okay, so all these are considered as the electromagnetic spectrum. Now, characteristics of electromagnetic spectrum. There are various characteristics are there. These electromagnetic spectrum also do not require any metal medium for their propagation, because they are associated with the light. Remember that all these are associated with the light. Okay, so that is why they are known as the spectrum. Okay, though they are not visible, some of the only the visible light we can see. Okay, but gamma rays, X-rays, ultraviolet radiation, all these are invisible. But though they are associated with the light. So when we talk about the characteristics, number one characteristic is electromagnetic waves do not require any metal medium for their propagation. Metal medium doesn't require any body to travel. Okay, light does not require any metal medium to travel. They can travel in a vacuum. Okay, with a speed of 3 to 10 to the power 8 meter per second. So similarly, this electromagnetic spectrum also does not require any metal medium. They obey the laws reflection and refraction. They obey the laws of reflection and refraction. They travel with the same speed of light, that is 3 into 10 to the power 8 meter per second. Okay, so all these are the transverse wave. So these are the characteristics of the electromagnetic spectrum. Okay, now let us come to the visible spectrum and invisible spectrum. Now the visible spectrum means like the visible spectrum are the visual 7 different colors. Because our eye can able to detect the spectrum having a wavelength. Our eye can detect or see the spectrum having a wavelength of 4 into 10 to the power of minus 7. 4 into 10 to the power of minus 7 to 7 into 10 to the power of minus 7 meter. So up to this wavelength our eye can detect. Okay, so beyond that, beyond 7 into 10 to the power 7, we cannot detect, our eye will not detect that spectrum. And also below 4 into 10 to the power minus 7 will not be able to detect with the eye. So therefore we cannot see beyond above 7.7 into the power minus 7 or less than 4 into 10 to the power minus 7 meter wavelength, we cannot see that. Okay, so therefore the visible light is having a wavelength ranging from 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7 meter. So therefore our eye can detect the spectrum having this wavelength. Okay, so these are known as the visible spectrum because we can see, our eye can detect the spectrum. Okay, so they are known as the visible spectrum. Okay, and visible spectrum lies between 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7 meter. Whereas invisible spectrum are there whose wavelength is more. Okay, invisible spectrum, that is whose wavelength is more, that is it comes from 4 into 10 to the power minus 7, that is infrared radiation. When we talk about the infrared radiation, its wavelength starting from 4 into 10 to the power minus 7 to 7 into 10 to the power of minus 4. Okay, so 4 into 10 to the power of minus 7 to 7 into 10 to the power of minus 4 meter. Okay, so that means infrared radiation they are having a wavelength. Okay, so minus 7 into the power minus 4. So that means this infrared radiation cannot detect with our eye. Even the ultraviolet radiation will also not be able to detect with the eye. So they are known as the invisible spectrum. So though they are concerned with the light, they are associated with the light, but some of the spectrum due to their wavelength, okay, we won't be able to see that. So they are known as the invisible spectrum. So these are both visible and invisible spectrum. So in the next class, we will come to the infrared radiation. Thank you.